Hello class, we're on lesson number 3 today, chapter 11, and we're going to be adding and subtracting fractions. Now, take a look below. We have some pies. If you ate 2/5 of a pie for lunch and 1/5 at dinner, what fraction of the pie would you have eaten altogether? So, you had 2/5 and you also ate 1/5. So, being that we have a common denominator, all we have to do is add the numerator. And we know that we ate 3/5. Now they gave us a simple little diagram there, and we can see that. Now this example illustrates the principle that to add two fractions that have the same denominator, we add the numerators. So we can say, in this case then, that A over B plus C over B is equal to A plus C over B. Now just take a look. What did we do? Well, we simply added 2 plus 1 to get 3. So 2 is the A and 1 is the C, and we add 2 plus 1 as we're adding A plus C. And they're over the denominator, in this case 5, we can see that we have the same denominator. We had 5. Okay, so now let's turn over to page 514. Now suppose instead that you ate half the pie for lunch and 1/3 of it for dinner. Now what fraction of the pie would you have eaten in this case? Well, look at the next two diagrams. So we had half of a pie. Alright, now this is a little bit more difficult because we do not have a common denominator. So we have 1/2 plus 1/3. Now what we have to do is we need to change the denominator. We need to have a common denominator, so we need to create equivalent fractions of the ones that we have. Now, based on what we learned in the prior lesson, we know that we can do that by simply taking and multiplying, in this particular case, let's say the denominators to create a common denominator, which means that I should be able to multiply this side by 3 over 3. It's equivalent. Remember, we're creating an equivalent fraction because multiplying by 1. And this side I'm going to multiply by 2 over 2. Okay, what that does allows me to create 6 as a denominator. So what do we end up with? Well, 3 times 1 is equal to 3, and 2 times 3 is equal to 6, plus 1 times 2 is equal to 2, and 3 times 2 is equal to 6. So now I have a common denominator of 6, and I can go ahead and add them. All I simply have to do is follow this, A plus C, right? Because B over, we have B as a denominator in both of these. Well, that B is now 6, so we can just simply say 3 plus 2, which is 5 over 6. So if we ate 1/2 and 1/3, we actually ate 5/6. Okay. From this example, we see to add two fractions that have different denominators, we must first replace one or both of the fractions with equivalent ones so that the new fractions have the same denominator. So now we're going to write something a little more complicated, but basically it's what we just did here. And let's take a look at this form. We have now A over B plus C over D. Okay, now notice that we have two different denominators. We have B and D. Over here we simply had B and B. Go ahead and add them. Over here it's a little more complicated, but what we did was we simply said, well, let's take A over B and multiply it by D over D, right? That's this D. And we're going to add, what do we have? C over D, and we're going to multiply it by B over B. Well, what does this do? It creates a common denominator. I have BD, and this is DB, but it's the same as BD. But obviously it does a lot of changing of our numerators, as we did in our previous problem. It changes that around. So how can we now express this? Well, we can simply say A times D plus B times C over BD. Now, for us to understand what this really means and to learn the shortcut, look at where we started. Okay, we started way up here with A over B plus C over D. This is where we started, right? Now we're looking at AD plus BC over BD. Well, just remember that when you're looking at two two different denominators. And we had the case here of 1/2 plus 1/3. Okay? Just know, I'm sorry, is that what we had? Yeah, 1/2 plus 1/3. Just know that I need to simply multiply. I'm sorry, I'm moving my pen around. It won't move. Okay, I simply need to multiply this by this denominator and this by this denominator, and then multiply these two together. That's basically what it is. So, and we add that. So in this case I put 3, in this case I put 2, and then I'm adding those two together. Remember, we had 3 plus 2 was 5, and then just multiplying these. That's really the shortcut way of thinking. Instead of saying, well, I got to do all of this, and then I have to come down and do all and express it this way. You can, and you probably should in the beginning, but ultimately the pattern is that when I have this denominator, I'll multiply it by this numerator, and multiply this numerator by this denominator, and then I just multiply these two together, and I will have my expression. Okay, AD, right? A times D plus, if this were minus, obviously it would be minus B times C, and then multiply the two together. So it's like 3 parts. Okay, there's 3 parts to it. That's the first part, that's the second part, and that's the third part. Multiply these two, multiply these two, and then multiply these two. Okay, now you can't see anything on my board, but you understand what we're doing. So that, in a sense, is kind of the shortcut. If you feel comfortable, go ahead and start doing it from the beginning. If not, you take your time and make sure you feel comfortable with your fractions. Especially, it's going to get a lot harder with algebra when we introduce algebra to it, but nonetheless, you get the idea. Now, let's let's look at some of these examples. We have to add 2/5 and 2/9, and as you can see, what they simply did was they took the 2/5 and they multiplied it by 9/9. This is example number 3. Actually, I'm sorry, I just jumped all the way to example number 3. Let's back it up. Let's back the train up. We have example number 1, and we have 1/8. And 3/8. So we know that we can simply add 1/8 over 3/8 and get 4/8, and then we can simplify it to 1/2, 4/8. You should always simplify. Now we're supposed to add 7x over 12 and x over 12. Again, we have a common denominator, and the common denominator allows us to simply add the numerators. We have 7x plus x all over 12. Now we have 8x over 12, but again, what are our common factors here? Well, we have 2 times 4 and 3 times 4, so we have 4 over 4. We get rid of that, and we end up with 2x over 3. Now, we're on example number 3, and we're going to add 2/5 over 2/9. Now, these fractions do not have a common denominator, so we replace them with equivalent fractions. So what do? We're going to go back to what we were just learning before, and when I jump to this, I probably could have just jumped to this because I think examples 1 and 2 are fairly simple, but we're now going to take the 2/5 and we're going to multiply it, both the numerator and denominator, by the other denominator, 9, right? So we end up with 9/9 times 2/5, or as they express it, 9 times 2/9 times 5. Now, let's do the same thing the other way. We have 2/9, which is 5. We multiply by 5/5, and now we have two fractions, 18/45 and 10/45. And with that, we can then just simply add and get 28/45. And again, if there is an opportunity, if you can find the factors, you should always reduce. I think of the factors of 28, and I don't have the equivalent factors or any like factors in 45. So it remains as is. And now we have adding x over 4 and x over 3. Again, they applied the same principle. Take the denominator of 1 and multiply it by both numerator and denominator by that. So we took the 3, the denominator, we put 3/3 times x over 4. We ended up with 3x over 12. And on the other side, we took 4/4, which is the other denominator, and multiplied it times x over 3, and we ended up with 4x over 12. So we can now take those two add them, and we end up with 7x over 12. And again, we do not have any like factors that we can cancel out, so we're left with that in its lowest terms. So if we go on here, we're going to see fractions are subtracted by the same method as they are added. These diagrams show, for example, that the problem 1/2 minus 1/3 can be solved by changing the fractions to 3 over 6 minus 2/6. So it's the same, we're just subtracting now. Okay? And we can see this, the same pi that we had before. Instead of adding them, we're subtracting them, and we ended up with 1/6. Now let's turn over to page 516, and we have examples of subtraction, and we have subtract 2/7 from 1/3. So 2/7 from 1/3. Let's see what we did. Well, we're going to take the denominators, and we're going to try to create a common denominator. In this case, it was 21. So we took 2/7 and multiplied it by 3 over 3. We ended up with 6/21, and we took 1/3 and multiplied it by 7 over 7, and we ended up with 7/21. Now we're supposed to subtract the 2/7 from the 1/3. So the 2/7, the 1/3 is what we're going to start with, and that will be 7 over 21, and we subtract 6 over 21, and we end up with 1/21. And we now have, again, another example. Now we're just going to introduce a variable. We have x over 2, and we from x over 2 we subtract x minus 1 over 4. So let's take this one to the board, and let's work it out, because it does get a little more complicated. We just need to apply all the algebraic rules that we've learned. And so we cleared up the board here. And let's write this out. Make sure I got my pen. And yes, it's writing. So let's start with x over 2. Well, from x over 2, that's x over 2, we're going to subtract x minus 1 over 4. Now, we do not have a common denominator, so we need to create it. So we're going to take that form. We're going to multiply this and this by 4, and we're going to turn around and do the same thing here. And how do we do that? Well, let's just clear that up and just do it. We're going to take x over 2, and we're going to multiply it by, well, I'm sorry, in this case we do have a common denominator, almost, let's say. They took a shortcut. And basically what the shortcut is to use 4. I'm going to go ahead and do the 8s because I want this to happen. I want to reinforce what we've been doing with the others. So I am going to take this and multiply this by 4 over 4. And I'm going to do the opposite over here. I'm going to say minus x minus 1. You might say, well, hold on, they're not doing it that way. Well, they're not. We are. You're still going to get the same answer regardless. We could have just taken this and multiplied this by 2 over 2. I end up with x over 1 minus 4. And we end up with 2x over 4 minus x minus 1 over 4. And we can certainly continue to simplify this by simply writing 2x minus x minus 1 over 4. Okay, and when we subtract x from 2x, what do we end up with? Well, it's going to be x minus 1 over 4. Okay, so I did it the way they did it, but I want to show you, again, I want to reinforce this whole issue that we've been having with using the denominator. So what would we have ended up with here? We would have ended up with 4x over 8 minus, what do we have here? Well, 2 times x minus 1. Now we could have written that out. I didn't do that on purpose because I wanted you to see something. Well, I wanted you to notice that we are multiplying here. So what do we have here? Well, we would end up with 4x over 8. And now we're going to multiply that out and end up with 2x minus 1 over 8. Okay, now we can go ahead and take that and express this. I'm just going to draw a line here so we can see we're working on a different problem. So we have 4x minus 2x minus, I'm sorry, this should have been 2. Okay, 2x minus 2 over 2 over, and this is all over 8. So what do we end up with? Well, 4x minus 2x would give me 2x, right? And minus 2 over 8. Now, if we left it there, you might say, well, that's not the same as this, is it? But we could simplify this, and simplifying this would have been to take the 2 out of the top and write this as x minus 1 over 2 times 4, right? So you factor out the 2 up here, and we would have ended up with 2 times x minus 1, and then we have 2 times 4, so by eliminating the 2, we end up with x minus 1 over 4. Now, this may have been a little more difficult to do it this way in terms of we could have taken a simple shortcut this way. And typically you will identify these. You will identify the opportunity to say, well, I can simply create a common denominator by just multiplying one term. And that's sometimes all you need to do. But I wanted you to continue to reinforce the idea of multiplying each. So, but you can see that it worked both ways. So that was that example. Let's just finish reading. Although the main purpose of this lesson has been to learn how to add and subtract fractions written as quotients, it is important to realize that arithmetical fractions can also be added and subtracted by changing them to decimal form and adding or subtracting their decimal forms. So we could do this with decimals. And decimals are a lot easier to add and subtract because we're just simply going to subtract the numbers. So if we would have taken 2/5 plus 1/5 as 3/5, in decimal forms it would have been 0.4 plus 0.2, or 0.4 plus 0.2, and that would be 0.6. And you may be able to see that 0.63 fifths is the same as 6/10, right? If you multiplied both numerator and denominator by 2, and 6/10 is the decimal 0.6. Now, this is the form in which problems in fractions are done on a calculator. So that is the end of this lesson.